What's going on, Algebra 2 students? Welcome to class. 1 second. Hold on. Okay, I don't need to sneeze. Ooh, all right. It's like I got a sneeze that's gonna come out. Give me a second. But so don't worry, you guys are on the other side of the island. So anyway, can you guys hear my voice all right? Is the voice coming through? Say yes, no, maybe, I don't know. You smell, you stink, all that kind of stuff. Awesome. Can you guys see my face? Is the face coming through? Say, I know, it's beautiful. I love your face. Awesome. Cool. Well, why don't we start off with going over this chapter right here. And so I'm going to try to get through all of this entire section today. Hopefully I can just finish it off. All right, let's check it out. If I start off with f of x equals it's negative 1/2 x squared plus 5x minus 8, okay? And they said that they want to graph this, okay? Let me think about something else. I know that this can also be written as f of x equals negative 1/2 x minus 2 x minus 8. If you don't believe me, foil this. If we foil this, and this is just side work here, okay? If we foil this, this becomes first, outer, inner, last. X times x is x squared. The outers is negative 8x. The inners is negative 2x. And the last is positive 16. So I have x squared minus 10x plus 16. Right? But when I multiply in the negative 1/2, I end up getting negative 1/2 x squared plus 5x minus 8. Hey, that's the same thing. So do you guys now agree with me that these two equations are exactly they're the same. They're not identical. They look a little bit different, but they're the same equation. You multiply it all out. You get it? Yes? No? I don't know? I don't understand? I do? Awesome. Is it right if I erase the scratch work part? Because this was just on the side. I was just proving to you that this was true.
Good.
Okay. Erase it. All right. So, this is warm-up, so we're still going to graph this thing. Okay. This is called standard notation. This is called factored notation or factored form. This is called standard form. I think this is called standard or factored form down here. From the standard form, I can get some information. Not a whole lot, but I can get some information. If I wanted to graph this thing. From the standard form, I can tell you whether or not this parabola opens up or down. Now you tell me, does this parabola open upwards or downwards? Alright, we got downwards from Erica. Who else? Come on, everybody chime in. If you don't know, say IDK, but everyone needs to answer. Say up, down, I don't know. Negative, IDK from Corey. Alright. Savannah, I don't know. Okay. The indicator, and I think this is what Kaylin and Erica are looking at, is this negative 1/2. That negative 1/2 there kind of tells you, see, if it's positive, it's going to be a parabola that looks like this. If it's not positive, it's negative 1/2. So we definitely have a parabola that is opening downwards. Now, I've shown you this before, right? Going up, going down. So I know our parabola is going to open up downwards. You guys agree? So, I'm just going to write some information down. Now, I got a question. Is this parabola skinnier or fatter? Is it vertically stretched or is it vertically compressed? Erica says wider. Wider. Now think of the gummy bears that I showed you once before. Alright? We got a lot of people chiming in on wider. Okay, exactly. See this 1/2 right there? That means vertically I'm pushing this thing together. Remember those gummy bears? When I pushed it together, it got fatter. So we got wide. I'll just put wider. So it goes down, it gets wider. I was able to get that from this number right here. There's one other piece of information that I can get from the standard notation right off the bat. This is probably the only thing that standard notation is really good for, to be honest with you. Actually, I lied. There is something else, and that's when we're using the quadratic equation. But absolutely, Erica, we can get the y-intercept. What is the y-intercept? -8, exactly. Because whenever you want to find the y-intercept of something, you always set x equal to 0. So if I plug in x equal to 0 here, I got 0, 0 squared, which is still 0, times -1/2. It doesn't matter because that's 0. 5 times 0, that's 0, so you got -8. So I know that the y-intercept is going to go down somewhere down here. And I know that it's going to open up like that. Got it? Now, the factored form, this is a real nice one because I can I can get 2 pieces of information from there. Do you know which 2 pieces of information I can get from there? So, y-intercept equals -8. This is just all of my information that I'm gathering. I look over here, I know it's going down, I know it's getting wider, I know it's going at -8. Yes, exactly, Erica. If I want to figure out the y-intercept, I plug in x equals 0. Now, if I want to plug in if I want to figure out what the x-intercepts are, and that is where this graph crosses this x-axis, then I would plug in y equals 0, or in this case, f of x. This whole thing equals 0. If that equals 0, then it's saying that -1/2 times something is equal to 0, or -1/2 times something is equal to 0. So there's these like 3 terms, okay? Now, if any one of these 3 terms was 0, like I have -1/2 times 0 times, I don't know, 42. It doesn't matter what this third number is, because if one of this is 0, then it doesn't matter how you multiply it out, or how big the numbers are you multiply them out, because it's going to equal to 0. Does that make sense to you? So in order to find the x-intercepts, and I set this thing equal to 0, I can either say that this first term equals to 0, or this second term equals to 0. So I have x minus 2 equals 0, or x minus 8 equals 0. I can simply solve for x. You just put it onto the other side, or 2 to the other side. So you have x equals 2 or x equals 8. Those are my x-intercepts. So I would probably want to redraw this a little bit. 1, 2, 3, 4, 5, 6, 7, 8. And then I know that my graph crosses here and here. So I've got 3 points, 1, 2, 3. I could draw my graph right off the bat. I think that it's probably going to look something like this. Do you guys see how I did that? I got the x equals 2, that's 1 intercept, x equals 8. Because if I plugged in x equals 2, then I'll have -1/2 times 0 times -6. Of course, it doesn't matter that that's -6, because if this is times 0, and all of this is multiplied in between, it doesn't, it's just going to, everything's going to die, and everything is going to be 0. Similarly, if I plugged in 8 over here, this would be -1/2 times 6 times 0. But that 0 kills everything else, so it doesn't matter what these are, that's 0, so therefore we're good. Does that make sense? We good? Yes, I like this kind of math, Mr. Baldy. No, I hate this kind of math, Mr. Baldy. Awesome. Awesome. Now, let's take a guess as to where the vertex is. I would say the vertex is right here, so I would say just by estimating it, it would be 1, 2, 3, 4, 5, maybe? 5, 4. That's my guess, 5, 4. Now, there's a for sure way to figure out exactly what the x-intercept, or the vertex is. By the way, I'm going to erase this part. Is that all right with you? Okay, erasing. No one said no. All right. There's a first sure way to figure out where the vertex is, because you know that if this is the x-intercept and this is the x-intercept, then the parabola is going to be symmetric about these 2 points. So if this is 2 and this is 8, what we want to do is we want to figure out, well, where is the middle of these 2 numbers? To figure out the middle, you just simply find the average. To find the average, you add up the number, you add up 2 numbers, and then you divide by the number 2. So you have 2 plus 8, that's 10, divided by 2 is 5. So we know that the vertex is going to be at 5. And x equals 5. But how do I know what the y value is? To be honest with you, this 4 I just guessed. But, my drawing could be off. I don't know. What you want to do is you want to take this x and you want to plug him into here. So this becomes f of 5 equals, now wherever I see an x, I'm just going to replace it with a 5. So I have negative 1/2 5 squared, which is 25, plus 5 times 5, which is another 25, minus 8. So let's see. What is 25 minus half of 25? Half of 25 is 12.5 minus 8. 12.5 minus 8 is 4.5. So I got close. I didn't get the right exact answer, but you know what? But at least I know that it should be close to what I got. To be honest with you, if I ended up getting a negative number over here, then I straight up know I did this wrong. Does that make sense to you? I know we're getting some feedback. 1 second. All right. So what I'm saying is, I know that I did this kind of right because my guess was pretty close to what the actual answer is. And the only reason why I make you do that, the only reason why I'm showing you how to do that is because, like, if you end up guessing that this thing's supposed to be at 12 and you end up calculating out 4.5, then either you're a terrible guesser or you did this wrong. Chances are you did this wrong, so you should go back and check it. You know what I mean? So if we were to graph this, I would argue that this is the graph. Without using a graphing calculator, I mean, you can always plug this into Desmos and see exactly what it gives you. But without using a graphing calculator, I'm able to glean these pieces of information. Let me go over it real quickly. I'm just going to go over my hand wavy exercise with you guys. What I mean by hand wavy is I'm not going to write anything down. I'm just going to show you guys 2 things. Okay, ready? These are the 2 equations that I got, that I was given, and I want to graph it. This is called standard form. This is called factored form. From the standard form, I'm able to get that this thing is going upside down because of the negative. I'm able to know that this thing is a little bit wider than a regular parabola because of that 1/2. And I know that the y-intercept is at negative 8. From the factored form, I can get the x-intercepts by setting y equal to 0. And so I have x equals 2 and x equals 8. If you look at it, it's really just the opposite sign of whatever's in here. Because you set this equal to 0 and this equal to 0. Now for the vertex, all you do is you find the average of these 2 x-intercepts. So 2 plus 8 is 10. Divide that by 2, that's 5. Boom, right in the middle. Then I can plug in the number 5 into either one of these things because these are the same equations. And figure out and calculate out what f of 5 is going to be. Does that make sense to you? Alright, I gotta move on. So, part number 2. Short review. George the slug on steroids is running back and forth along my porch. I'm watching him from my front door. He starts on the porch on one side of the door and grabs some cookies and fell on the table and runs very fast to the other side. What is it? Why can't it be George the mongoose? I mean, like, why do you have to, like, vouch for this thing being on steroids? Why can't you just make it a mongoose, which is inherently fast? I mean, we're not dealing with turbo here. Anyway, whatever. The graph looks like this, apparently. something like that. Now, where was George 1 second after the stuff? Where's the cookies, I guess? That's the question. So if George starts here, and he's going to the right, I'm assuming that it says here that he's running towards the cookies initially, grabs some, then runs back. So I'm assuming that the cookies are on this side. And I was looking at this and I was like, how is it negative? Then he said, well, anytime it's negative, that means he's on the left of the door. Anytime he's positive, he's on the right of the door. So I'm just going to write left and right. So this is, when he's on this side of the graph, he's on the left of the door. On this side of the graph, he's on the right side of the door. If you're confused, just turn your head 90 degrees like this, and then you realize, oh, I see it. Got it? Now, P of 1 is right around here. So, is he running towards the cookies or away from the cookies? Write your answer down. Towards, away, or I don't know. While we're in class, I don't know is a perfectly fine answer. Of course, towards and away is the ones I want you to give me, but... Alright, you think it's towards? Away? Towards, away? Oh, I've got a mix. I've got a good mix of towards and away. Alright, no, that's fine. That's fine. Alright, check this out. I'm definitely saying that the cookies are towards the top. So when he's on this side over here, he's running towards the cookies, right? And he grabs the cookies right about here, and then just kind of makes this straight up turn, and is now traveling away, in the away direction of the cookies. He is actually directly in front of the door. I agree with you. But if the cookies are here, he's running towards the cookies over here. He's running away from the cookies. And here's his lounge. Of course, how many snails do you know have lounges? I don't know. But this one, who apparently takes steroids and runs very fast, has a lounge. Alright, fine. Snail who takes steroids and runs very fast is allowed to have cookies and have a lounge. Running towards, running away. Got it? Now, that brings up a good question. I'm going to ask that question to you. When is the snail exactly in front of the door? Erica, you can answer because you said it 3 times. When is the snail exactly in front of the door? Well, you got all of the answers. Yeah. Exactly. We're talking about these x-intercepts right here. Yeah, I don't know. You must have had those. Because that means he's not to the left of the door. He's not to the right of the door. He's right in front of the door at that given moment in time. Apparently, this part of the door, he's going to the right. Over here, he's going to the left. And over here, he's going to the right again. But if I were to write these equations down, this would be like P3, P1, and P negative 1. Yeah. Does that make sense to you? And by the way, P negative 1, P1, and P3, they all equal each other. They equal 0. Because it equals the y value, and the y value for this x-intercept is 0. This is what the x-intercepts. That means he's directly in front of the door. So this says, what does this say though? Does this say P times 3? By the way, P stands for position. Yes. I remember teaching you guys about notation. What this says is it's not P times 3. This is P as a function of 3. So this is P that is evaluated at 3 seconds. Exactly. Now P stands for the position, so if I give you P of X, then I would tell you the position at any given time. Now the particular time that we're talking about is 3 seconds, so that's why I have a 3 there. Cool? Alright, now on to page 3, because this is what confused some, one of you. A couple of you, maybe. Some of you. Suppose that f is a function that satisfies this. F of x plus 3 equals 2 times f of x. For each of the x and g, or for each x and g satisfies this. G of x plus 3 equals g of x plus 12 for each x. The graphs below. Oh, that's kind of a crazy one, but let's try it. Let's figure it out, because that's a little bit weird. I'll admit to you, I understand where your confusion is. What does this graph look like? Okay, let me think. What this is saying is, we want to evaluate these 4 graphs. Do you see them? 1, 2, 3, 4. Now, I'm gonna just do one of them. I'm going to try one of them. Let's try graph B. Okay? This is my try. Alright. So I guess the f of x is going to be one of these, and g of x is going to be one of these, and then 2 of them are extra. But here's the way I would probably test it out, because I would say, well, let's try a graph. Let's try what is f of 0? If this were graph B, what is f of 0? What's the value? F of 0 equals what? What's the y value of if you evaluate this graph at 0? It's about 1. Yes, I agree. What is f of 3? No, f of 3 is about 2. You see that? So, I'm going to look at this graph right here. And if I plug in 3 for x, the y value that I get is about 2. Okay, so, here's my question. Is this true? I'm going to plug this information into here. F of 0 plus 3 is equal to 2 times f of 0.
I think so too. I think
Alright, f of 0 plus 3, that's really just asking for what is f of 3? Right? F of 3 is 2 equals 2 times f of 0 is 1. So is 2 equal to 2? Absolutely. Well, if that's the case, I would say that graph B looks very close to what I want to see for f of x. I would say that graph B is f of x. Do you guys see that? How does f of 0 equal 1? Well, it's right here. But if you look at it, like f of 0, what this is asking you is, this curvy line is the function. And we can represent that function as a graph. We could represent it as an equation, but we didn't happen to give you the equation in this case. So f of 0 is saying, what is the y value of this curve at x equals 0. Well, at x equals 0, the y value is 1. Yeah, this is a coordinate. This is saying that x equals 0. If x equals 0, then y value equals 1. Does that make sense to you? I'm just reading the coordinates of this thing. Like, for example, f equals 3, the y value is equal to 2. Here, let's try this. Let's try out some different numbers. If f equals 6, what does y equal to? If f equals 6, what is y equal to? 4. Exactly. And you can kind of just guess it, really. So you got 6, and it goes up to about 4. Notice how what I'm doing is I'm choosing strategic numbers, because I don't want to know what f of 4 is, because it doesn't seem to land on a very nice number that I can read. So that's why I'm choosing 6, because 6 seems to land on a very nice number. It's easy to read. So here, check this out. F of 6 is equal to 4, right? So what I'm asking you is, if I plug in 3 into here, I've got f of 3 plus 3, right? If I plug in 3 as x over here, I've got f of 3 plus 3, which is 6, is equal to 2 times f of 3. Well, what is f of 3? That's 2. What is f of 6? That's 4. So is 4 equal to 2 times 2? Yes, it is. Oh, wait, who says no? 4 equals 2 times 2. Of course. Yes, 4 equals 2 times 2. And if you don't know that, that's not an Algebra 2 question. Maybe you can't see the times. There we go. Can I erase? Are we good? Do you understand? Right. F of 6. Now this doesn't say f times 6. This is saying f, the function is being evaluated at 6. So you look at the graph and you evaluate it at the number 6. Then you figure out what the corresponding y value is that is related to that 6. Can I erase? So I did f of x for you. I figured out what f of x is. It's your job to figure out what g of x is. And you know it's the answer, not b. So we go over what? You want to go over completing the square. Fair enough. Sam, do me a favor. Find a problem that is... I don't think the completing the square is in this packet. Find a problem that's in completing the square, and I'll go up to about 9:40 with this class. Do you guys have another class after this? No? Alright, then I'll spend 10 minutes on completing the square after I'm finished with this class. But look up a problem for me for that one. Cool? Alright. I'm going to erase. Alright, let's do another one. Ready? These aren't that bad. Alright, let's do... Okay. Tony's market analysis. I'm doing number 4 on page 4. I'm going to try to get through... This is average rate of change. This is the oil spill. Big glut. Dow Jones. All right. Let me do one of these problems and another one of something else. All right. Tony's market analysis tells her that the profit in thousands of dollars is for making X batches of pencils with 1,000 pencils per batch is given by this. All right, Sam. What I'm saying is, never mind, Sam. Just stay a little bit after class. I'll teach you complete square. Anyway, I'm on number 4, page 4. So we've got the pencils of X is equal to 1/2 X squared plus 5X minus 8. That's actually profit, I think. That stands for profit. What a coincidence. This is the same function you investigated in warm-up exercises. Oh, okay. All right, fine. Whatever. All right. Compute the following quantities. What is P of 3? Well, all it's asking you is, this isn't P times 3. What this is asking you is, wherever you see, all we did change here was we have P of X and we're given the equation, but instead of having a X, we decided to replace it with a 3, so all we do is we take this equation and replace it with the 3, so we have 1/2 3 squared, which is 9, plus 5 times 3, which is 15, minus 8, and then you just compute it out, so half of 9 is what? That's 4.5 plus, so that's 19.5 minus 8, so that's 11.5. Does that make sense to you? All right, I'm going to do part C, because part C looks really tough. What is P of X plus 3 minus P of X? Okay, here, let me show you how to do it. It's not that bad. Ready? Let's figure out what P of X plus 3 is first. When I did this problem over here, I saw that what they wanted me to do was replace the 3 with replace the X with the number 3. Okay? Over here, this P of X plus 3, this guy right here, what they're wanting me to do is replace every time, they write this equation down, but every time I see an X, I'm going to replace it with X plus 3. I did this because I make sure you remember the parentheses. It's parentheses X plus 3 because I'm putting in that whole package, whatever's inside here, into the X. If they ask me for what is a P of a happy face, well, that's equal to 1/2 happy face squared plus 5 happy faces minus 8. See, all they did was they said, what is a P of a happy face? And so you just take this equation over here and write it down again, but instead of writing X's, you write happy faces, because that's what they told you to do. Now, of course, if you P on a happy face, I'm sure that it will end up being equal to a sad face, but that's a side joke. All right, does that make sense to you? All right, so what I'm going to do is I'm going to rewrite this equation over here, but instead of an X, I'm going to put an X plus 3 squared plus 5 times X plus 3 minus 8. Does that make sense to you? This is the same thing. This is what that means. Good? Bad? Do you get it? Do you understand where it comes from? Yes? No? Help me out here. Tell me what your thoughts are. You lost? Do you understand this? Where is the negative px? Okay, Erica, I didn't put in the negative p of x part yet. I'll put that in right now, but I want to make sure you understand the p of x plus 3 part. All I did was I got what they told me what p of x is equal to, and I put in instead of writing an x, I put an x plus 3. Now I'm going to put in the minus p of x part. All I got to do is minus this thing. 1/2 x squared plus 5x minus 8. Sorry, it's off the screen. Minus 1/2 x squared plus 5x minus 8. You have to be very careful because you want to subtract all of this, which is why I put a parentheses around here. If you don't put the parentheses, it looks like that minus only goes to the 1/2 x squared. But I want it to go to every term in here because I want to subtract this whole thing at the end. Do we get it?
Oh, stop it. Agreed.
Okay. The last part of simplifying this, and this isn't so bad, but let me show you how to simplify this. This right here, this is 1/2 x squared plus 9. Does everyone agree? Yeah, now someone's audio turned on. Sam, that's you. I got it. Does everyone agree with this? This is the same thing. 1/2 x plus 3 squared is 1/2 x squared plus 9. Say yes or no, I agree, I don't agree. Yes, Erica, good. Everyone chime in. Yes, no, I don't know. Yes. Yes, yes. IDK. IDK from Cougar. Yes, from Kaylin. No, the answer is no. No, no, no. Oh, this is you. This is, hi, Mr. Dalday. Yes, you're correct. No. Oh, I hurt my finger. No. When you square this, you cannot simply distribute that square. That is bad, bad math. I'll tell you what it is. This is this. You remember? X plus 3 squared is x plus 3 times x plus 3. FOIL that, that's x squared plus 3x plus 3x plus 9. X squared plus 6x plus 9. Don't ever think that this is x squared plus 9. You just put the square here and the square here. That is wrong. You can obviously see that these are not the same. I mean, you have the x squared, you got the 9s, but you're missing this thing, which is super important. Okay? So even, well, at least Cougar said, I don't know. Everyone else, psh, psh, psh. No. Next time you guys do that, I'm going to take my slipper and whack you guys in the head. Alright. So let me do this part right here. This is plus 5x minus 15 minus 8 minus 1/2 x squared minus 5x plus 8. All I did at this point, all I did was I distributed this thing. I distributed this 5 in here, and I distributed this negative in here. So that's negative, negative, and a positive. Did I go too fast for anyone? You don't understand what I'm doing with the negative px. All I did with the negative px, Erica, is the negative px is right here. See, I double underline it right here. This is it right here. It's the minus whatever's px is. Now wait a second. Wouldn't it be 4? Wouldn't what be 4? What are you talking about? Oh yeah, I'm not finished distributing. Okay. I'm going to distribute this 1/2. So I have 1/2 x squared plus 3x plus 9/2 plus 5x minus 15. By the way, no, let's just leave it. And minus 8 minus 1/2 x squared minus 5x plus 8. And I'm going to combine the things that are alike. Okay. The 1/2 x squared and the negative 1/2 x squared, they kill each other. The negative 8 and the positive 8 does kill each other. This 5x over here and this minus 5x kills each other. All I'm left with at this point is a 3x plus 9/2 minus 15. 9/2 is 4.5, so minus 15 from that, that's negative 11.5. This is my answer. Oh, snap. You're absolutely right. I wrote the problem down wrong, Erica. I see why you're confused. I'll write it in red. Let me find my red pen. I wrote the problem down wrong. This was supposed to be a negative number, right? That's what you're saying? Is that what your problem is with it? All right, I'm sorry. I'm really sorry about that. You're right. That's negative. That would make this negative. That would make this negative and this positive. Okay, this is going to get ugly. I'm sorry. You're absolutely right. It's hard to see from here. It doesn't change what I did per se. It just changed the math just a little bit. The concepts that I was doing is still the same. I just messed up the sign a little bit. I forgot that negative. I couldn't see it from here. Let me fix it for you, but I don't have to go through and redo the whole problem. All I got to do is just make sure I take all of that stuff into account. So I'm going to do all my corrections in red. So this becomes minus 1/2 x squared minus 6x minus 9/2 plus 5x minus 15 minus 8 plus 1/2 x squared minus 5x plus 8. I believe that's correct. See this negative 1/2 x squared? That still gets killed by this positive 1/2 x squared. 8 still gets killed with 8. 5x still gets killed with 5. So I have negative. Oh, I'm sorry. And this is not negative 6, this is negative 3. Because when I multiply it by 1/2, 6 times 1/2 is 3. So I have negative 3x minus, okay, and this would be minus 19.5. This is my answer. All because I messed up that small negative. I'm sorry, I apologize. I can see why you guys were confused. Does that make sense to you? Alright. I didn't get to finish all of what I wanted to talk about. I think I'll cover a little bit of this later on. But we'll move on after this. Alright, I'm going to erase this. I'm going to show you one more trick. And this was per the request of Sam. Can I erase? You guys can take a picture. Alright. This is actually not review anymore. We are now in the territory of Algebra 2. Do you guys feel like this is new stuff, or do you guys still feel like this is review for you? Oh, I'm so sorry. I thought you were going to take a picture. This is still review for you? Okay. Well, let me make up a problem, Sam. You're free to go at this point. Let me make up a problem. Let's see. X squared, let's make it 2x squared plus 4x minus 7 equals 0. Oh, you can't see that, sorry. 2x squared plus 4x minus 7 equals 0. Got it? All right. What I want to do is I want to solve for x. I want to get x all by itself. So let's just try that real fast. I'm not going to ask questions. I'm just going to talk my way through this whole equation. Tell me if you guys get lost or confused. I'm going to solve for x. I've got 2x squared plus 4x equals 7. I can factor out an x, and so I can factor out a 2 as well. So I have 2x times x plus 2 equals 7. But I still can't solve for x. I can't get x all by itself. There is no real algebra 1 way of going about doing this. So the other thing that I do is I say, okay, well, let me try factoring this. Can I factor this down? 2x, x. Let's see, I want to have something that multiplies out to be 7, negative 7, and adds up to be 4. So let's try 7 over here and a 1 over here minus a plus. Because positive 7 minus, by the way, that's 7. Positive 7 minus 1 is equal to negative, or times, positive 7 times negative 1 is equal to negative 7. Does that FOIL out correctly? That's 2x squared minus 2x plus 7x minus 7. This becomes 2x squared plus 5x minus 7. This isn't correct. Wrong. So I can't factor this. I'm not able to factor this. All right, now we're stuck. So what we're going to do is we're going to use this trick called completing the square. Now what you do is I'm going to tell you the steps. You can write them down. I'm not going to write down the steps for you because this is going to take way too long and I'm already past overdue my time. The first step I'm going to do is when we complete the square, we never really want to have a number in front of that x squared term. So the first step I'm going to do is divide out 2 out of everything. So I have just x squared plus 2x minus 7 halves equals 0 over 2, which is still known as 0. Now what I'm going to do with complete the squares, I'm going to do this stupid trick. It's not a stupid trick, but it's like this silly trick. If it's all right with you, actually what I'm going to do is I'm going to write x squared plus 2x minus 7 halves equals 0. I didn't change nothing. All I did was I put a big space in between here. Okay? But I didn't change anything. What I'm going to do is I'm going to take the number in front of the x term. I'm going to divide him by 2. So 2 divided by 2 is equal to 1. And I'm going to square him. So that's still equal to 1. So I'm going to say plus 1 over here. Okay? Now you don't exactly need to know why I did that, but you understand that all I did was I added 1. Okay. So what I'm going to do is I can't, since this is an equation, I can't just add 1 to the left side. That's not fair. That breaks the equation. It's no longer equal to each other because you just added something to one side only. So what I'm going to do, I can have one of two options I can do. I can go minus 1 over here, or I could add 1 to that side. So if I added 1 to the left side, I'll add 1 to the right side. It's the same thing. Because look what I did, was I said, all right, I'm going to do plus 1 minus 1. What is 1 minus 1? 0, exactly. So I can add 0 to the equation as much as I like, and no one's really going to care, right? So I added 0. That's all I did, was I said plus 1 minus 1. I'm adding 0. I didn't change the equation. I'm just making it look funny. But this right here is beautiful, because this right here is x plus 1 squared. I can factor this. I'll show you. You have an x here and x here. You put plus plus. You want to find two numbers that multiply out to be 1 and add up to 2. Oh, that's that. So this is x plus 1 squared. Okay? What's going on, dude? All right. Now the leftover junk that you have left is this minus 1 and the minus 7 halves. What is that, minus 4 and a half? That's it. So this negative 9 halves is really what I have underlined over here. And this thing right here is really what I have double underlined. Or actually in this case it almost looks like it's triple underlined. Sam, did I lose you? Are we good? Alright. By the way, this is equal to 0. And at this point, you can now solve this problem. You can simply say, alright, x plus 1 squared equals positive 9 halves. There would be a problem if it was negative. I just put the 9 halves onto that side. Take the square root of both sides, and I get x plus 1 equals plus or minus the square root of 9 over the square root of 2. So x equals negative 1 plus or minus 3 over the square root of 2. That's your answer. Which makes sense as to why we weren't able to guess the factors off the bat. We weren't able to go x, x, and then like figure out what numbers are supposed to go. Do you distribute the 2 or no need, I guess? This 2, well, mathematicians don't like square roots in the denominator. That's just a thing for them. So what you would probably do is you'd probably multiply this by square root of 2, multiply this by square root of 2, and then this becomes square root of 2 times the square root of 2 is just 2. And I guess if you wanted to, you can make them over the same denominator. So really what your answer is x equals negative 2 plus or minus 3 square root of 2 all divided by the number 2. This is technically the same exact thing as that. This is the most prettiest form. A true mathematician will give you credit for this. I'll give you full credit if you get here. But technically, you're absolutely right. You don't like square roots in the denominator, so and usually you might want to put it over the same fraction. Erica, does that make sense to you? Oh, the 2 in the beginning? This 2 right here? No, we don't distribute that because I would have distributed if it had a big parentheses around it. Then I would throw the 2 in all the way. But I don't, in completing the square, that's kind of one of the first steps is we don't really know a good way to complete. The trick doesn't work unless the number in front of the x squared term is 1. So in order to get it that way, I divided everything by 2. But that's fine because that's a perfectly fair operation if I did it to everything. Divide this by 2, I divide that by 2, I divide that by 2, and I divide 0 by 2. Dividing 0 by 2 is just 0. So we have x squared plus 2x minus 7 halves equals 0. Then I did my dumb trick. Right there. Take the number here, you divide that by 2, you square it. So if the number over here was 3, if I had 3x to deal with, I would take the number 3, I would divide it by 2, that becomes 3 halves, and I square it. So that becomes 9 fourths. So I would add 9 fourths and subtract 9 fourths. Good? Awesome. All right, have at it. I'll see you guys on Wednesday, 9 o'clock. We go all the way to 10:30 that time, though. All right, talk to you guys later.